I'm a big fan of Legos, Connects, Lincoln Logs, really any little toy you can use to build stuff. Think of building with Legos. You have this one basic stud piece. If you take that piece and combine it with others, you get longer multi-studded blocks. And if you start stacking those, you can make something that looks like a wall. From there, you can start building all kind of things by manipulating the way the blocks go together. In today's lesson, we're going to establish the foundation we will build upon in geometry this year. Now let's look at some of the actual terms in geometry. The first one that we're going to look at is a point. This is like our single stud piece of our Legos. All a point indicates is a location in space. A point is just kind of like a dot that's hanging out. We represent a point with a capital letter. Here you can see in our little picture that we have point A. Typically we just use regular old capital letters for points. The next term that we have is a line. Lines are like if we take our Legos and we start making bigger single pieces, right? So it's a straight path that extends in two opposite directions without end, it doesn't have any thickness, and it contains an infinite number of points. When we look at lines, we have a couple different ways that we can name them. We can name a line by listing two of the points that are on that line, and it doesn't really matter what order we give those in, and it doesn't matter which 2 points we pick as long as we pick 2 points that are on the line. The other way that we can name a line is by using a script letter. So here you can see I have line L. Our final term that we are looking at right here is a plane. It's a flat surface that extends without end and has no thickness. It contains infinitely many points, and it also contains infinitely many lines. So a plane is kind of like once we start stacking those Lego bricks up, we can start building things with them, right? So when we have a plane, we either represent it by listing 3 different points that are on the plane, and it's important that those points are not on the same line. Okay, so 3 points that are not all on the same line. We can also use capital script if we would like to do that. Planes are kind of hard to draw on a piece of paper because we're trying to represent a 3-dimensional object on something that by its nature is 2-dimensional. So typically when we draw a plane like you see here, we just draw a shape. Kind of like if you were to draw a 3-dimensional cube, all of those are just different flattened shapes, right? And in fact, if we look at a 3-dimensional object, each of those faces are kind of like a plane that's been cut off. Now let's look at these two terms. We have collinear and coplanar. Think of some words that you know that have the prefix co. Words like co-worker or cooperate or corporation. That prefix co means together. So we have collinear, and if we look at the word linear, right in the middle we have line, and coplanar, which the root there is plane. So if we have collinear points, those are points that are on the same line. They're on the line together. Coplanar are points that are on a plane together. So in these pictures that I drew, the first one we can see that point A, B, and C would all be collinear because they're on the same line. However, point X is not collinear because it is not on line AB. When we look at coplanar, in the picture that I have, points A, B, and C are coplanar with point X because they're all in the same picture. We can also say that line AC is coplanar with point X. Now let's practice looking at a figure and coming up with some names for some things. This first question says, what are 2 other ways to name line QT? We know it's a line because of the 2 arrows at the top, so we're going to look at our picture and find line QT. So we need to find point Q and point T, and now we've identified line QT. So to come up with 2 other names for it, we can pick 2 points that are on that line, or we can use a script. So for example, I could say line NT or line M. Those are some different ways to name line QT. Two other ways to name plane P. Well, looking at our picture, here we've got that kind of italicized script P. So this yellow plane, which again, it just looks like a shape because we can't really picture it well. Some other ways to name it, well, we could say that it is plane RQV, and that would be one. We could also say RSV if we wanted to. We could not say RQS because those points are on the same line. The next one asks to name 3 collinear points. Collinear means line together. So we need to figure out which line we want to use. So we could use line M, and then we could say 3 points that are on that line are N, Q, and T. Finally, it says name a point not coplanar, which means not on the same plane as R, S, and V. So a point that is not on this plane, well, this line here, line M, passes through the plane. That's kind of what these little dots behind mean, is it goes kind of perpendicular to the plane maybe. We'll get to what that is later. But so we can pick any point on this line and it will be not coplanar with the points listed. So here I would just say that maybe point N is not coplanar with R, S, and V. Now that we have all of the basic building blocks, we can start looking at different ways to put them together. The first thing that we're going to cover is a segment. A segment is part of a line that consists of 2 endpoints and all of the points on the line between those endpoints. So if we want to name a segment, we just use the 2 endpoints, and the order doesn't matter for this. So here we have segment XY. The next piece is a ray. A ray is part of a line that consists of 1 endpoint and then all of the points in one direction. So it's kind of like we've cut the line in half. We name a ray by its endpoint and another point on the ray, and the endpoint is always listed first. The second point is going to tell us what direction the ray is going. Then we also have opposite rays. Opposite rays are 2 rays that share the same endpoint. So they're going to go opposite directions, but they're going to have the same endpoint. Now take this opportunity to look at the example at the bottom of the screen here and try to name 3 line segments and name 4 rays. And then look for some opposite rays. I'll give you just a minute to do that, and then I will throw some of my examples up here on the screen. So go ahead and pause the video, and then when you're ready to see my examples, you can unpause it, and we'll go on from there. The last things I want to look at today are some things called postulates. These are kind of like definitions. They're just some facts, some information. We'll get more into what postulates are a little bit later. But these are the ones that we're going to start to begin with. So the first one is that through any 2 points, there is exactly 1 line. So no matter what 2 points you give, if you draw the line between them, that is the only line that exists between those points. The next postulate says if 2 lines intersect, they intersect in exactly 1 point. The third postulate that we have is if 2 distinct planes, meaning 2 totally different planes, intersect, they intersect in exactly 1 line. The final postulate that we have here is through any 3 non-collinear points, there is exactly 1 plane. So again, through any 3 non-collinear, means not on the same line, points, there is exactly 1 plane. That does it for today's lesson. I hope you have a good day or evening or weekend or whatever it's about to be. And I will see you when I see you.